Good evening, sir.
Yeah, good evening. Good evening, everyone. Let's just wait for 2 more minutes to allow few more participants to join. Hello, am I audible?
Yes, sir.
Yeah, I think then we should start now. Alright. How to make the screen bigger? So my screen is visible, right?
Yes, sir.
So as I have told in the earlier class that today I am going to discuss about quantum mechanics in 3 dimensions. and a specific example of hydrogen atom. So first I'll briefly tell about the theory part, and then we'll solve some related gate questions. So quantum mechanics. In 3 dimensions. So the Schrödinger equation is H psi equal to E psi. For 3D case, the Hamiltonian is 1 by twice m px square plus py square plus pz square, and the potential will depend on x, y and z in 3D. Now since px equal to minus I h bar del x, and similarly py is minus I h bar del y, and pz is minus I h bar del z. So the Hamiltonian will reduce to minus h bar square by twice m del 2 del x2 plus del 2 del y2 plus del 2 del z2 plus v x y z. So the Schrödinger equation will be minus h car square by 2m, this del 2 del z2 psi plus v psi equal to E psi. This is Laplacian operator. It can be represented by this also. So this is the representation in Cartesian coordinate. In spherical polar coordinate, the Laplacian operator nabla square is represented as 1 by r square del r of r square del r plus 1 by r square sin theta del theta of sin theta del theta plus 1 by r square sin square theta del 2 del phi 2. Then the Schrödinger equation in spherical polar coordinates will be minus h cot square by 2sm into 1 by r square del r of r square del psi del r plus 1 by r square sin theta del theta of sin theta del psi del theta plus 1 by r square sin square theta del 2 psi del phi 2 plus v psi equal to E psi, where psi is function of r, theta and phi. So to solve this Schrödinger equation, we will separate psi as a function of r and theta phi. This is called separation of variables. Now if we put this separation of variables in this equation, we will get a equation for this radial function and this angular function. So I am not going to do it explicitly. I will directly write down the equation for the radial part, and this is given by this equation Vr minus A r equal to L into L plus 1 r. Now this is to solve this equation, it is easier to solve if we replace like this. Then the equation involving u will be given by these expressions: v plus h bar square by 2sm L into L plus 1 by r square u equal to eu. Now if we see, then this equation is similar to the 1D Schrödinger equation, only here the potential V effective is V plus h cut square by 2sm L into L plus 1 by r square. So this is exactly similar to the 1D Schrödinger equation, only here the effective potential is written in this way, where this is called the centrifugal term. This term is called the centrifugal term. Because this term will tend to throw the particle outward way, and this is similar to classical centrifugal force. So we got the radial equation. This is called the radial equation. Similarly, there will be another equation for the angular part, and that equation is sin theta del del theta sin theta del y del theta, where y is function of theta and phi, plus del 2y del phi 2 equal to minus L into L plus 1 sin square theta of y. Now since y is function of theta and phi, we can solve this equation again by separation of variables. We have written this y, separate this into function. One is function of theta and the other one is function of phi. And if we do that and put in this equation, we will get one equation for theta and one for phi. The equation for theta will be sin theta d theta of sin theta d theta of plus L into L plus 1 sin square theta equal to m square theta. And another equation which is for phi, so this is easy to solve. This will only give us this kind of form, where m is 0, plus minus 1 and plus minus 2, and we can solve this equation also, and this will give us associate Legendre polynomial, where x is cos theta. So together these two function, this ylm is called these are called spherical harmonics. The angular part together called spherical harmonics, which will give us some constant value into e to the power m phi, that will depend on m and L and plm cos theta. So to get complete wave function, that is psi lm n lm r theta phi, we have one radial part which will depend on r, and this spherical harmonics, these are dependent on theta and phi. So our normalization condition will be mod psi square r square sin theta. This is the volume element, so mod of psi square, and this volume element r square sin theta dr d theta d phi is equal to 1. We can separate the angular part and the radial part. This is mod r square of r square dr, and here the angular part is y square sin theta d theta d phi equal to 1. If we write separately, then 0 to infinite r square of r square dr equal to 1. This is the normalization condition of the radial part, and similarly theta goes from 0 to pi, phi is from 0 to 2 pi, y square sin theta d theta d phi is 1, and this is the normalization condition for the angular part. Now one real example of this spherical polar coordinates, we can apply this to hydrogen atom. This will be applied to hydrogen atom problem. So hydrogen atom is basically, it consists one proton and one electron is evolving around this proton, and the distance between them is r. The potential energy, which is Coulomb potential, is only dependent on this distance r. So the potential for hydrogen atom is minus 1 by 4 pi epsilon naught E square by r. So the spherical harmonics we know ylm, but we need to solve the radial equation to get the complete wave function. So now we know the exact form of this potential, so we can put this in the radial equation, and we can seek for the solution of this equation to get the complete wave function for hydrogen atom. So this is our radial equation. Now we can solve this equation in the similar way as we did for harmonic oscillator, the analytic way. And this is a lengthy calculation, and I am not going to do this calculation. You can find it in Griffith or in any quantum mechanics book, and the final expression for the energy will be minus m by 2 h bar square E square by 4 pi epsilon naught whole square 1 by n square, which is also equal to E1 by n square, where n is 1, 2 and so on, integer values, and E1 is m by 2 h bar square E square by 4 pi epsilon naught. This is the ground state energy for hydrogen atom, and all the values we know, the value of me, that is mass of electron, the charge of electron, and epsilon naught. If we put these values, we will get minus 13.6 electron volt. So this is actually the binding energy of an electron, that is, we need to put this much of energy to ionize a hydrogen atom. And here I will write the ground state wave function for hydrogen atom, which is basically r theta phi equal to 1 by root pi a cube. This is the ground. You should remember this ground state wave function because this is very handy. So this is the ground state wave function, and we see that in any wave function we have three quantum numbers n, l and m, where n is called principal quantum number, n is principal quantum number, this comes from the radial part, and l and m comes from the angular part, where l is orbital quantum number or azimuthal quantum number, and m is magnetic quantum number. These numbers arise from the space geometry of electrons. These three numbers come, these quantum numbers arise from the space geometry of electrons. And another quantum number, which is called s, will come from electron spin. Now, given that theory, we can solve few questions related to this theory. So let's solve few questions and the theory will be more clear. So the first question is from 2011's GATE physics question number 15. The normalized ground state wave function of a hydrogen atom is given by psi r equal to 1 by root 4 pi 2 by a to the power 3 by 2 e to the power minus r by a, where a is Bohr radius, and its value is 0.53 angstrom, and r is the distance of the electron from the nucleus located at the origin. The expectation value 1 by r square is, we need to calculate the expectation value of 1 by r square. So I think you guys should try it first and then I'll solve it. So let's try first. This is not difficult, just you need to find the expectation value of 1 by r square. The volume element I am going to read is r square sin theta dr d theta d phi. So let me know when you get the answer. I had to cover the theory very briefly and fast because otherwise we won't get time to solve questions. The motive of this session to solve GATE questions. So I think are you approaching it? Hello.
Yes, sir.
A is basically, we write the expression of A, it is 4 pi epsilon naught h bar square by a b square, and it is 0.53 angstrom. Yes, someone has, yeah, Priyanka has solved it and she said that it is option D, and I think it is option D. So let's solve it. This is really an easy problem. So psi r is given as 1 by root over 4 pi 2 by e to the power 3 by 2 exponential minus r by a. This is given the wave function. So we are asked to calculate the expectation value of 1 by r square. So the expectation value of 1 by r square is 0 to infinite. Let's first not specify the limit. So integration, what is need to calculate is psi 1 by r square of psi. So this is basically 1 over 4 pi 2 by 8 square and e to the power minus 2 r by a. If we square it, then e to the power minus r by a is e to the power minus 2 r by a and 1 by r square, and then the volume elements. But since this psi is only dependent on r, we can write it the volume element as 4 pi r square dr, because there is no theta or phi dependence. So the angular part of the volume element will only give us 4 pi. So I have written it as 4 pi r square. So this 4 pi and 4 pi will cancel out, and the constant term, which is 4 by a cube, will come out of the integration, and the limit is 0 to infinity, and this r square will cancel out, so only exponential minus 2 r by a dr. And if we do the integration, what we get is minus 2 r by a minus 2 by a, limit 0 to infinity. So 4 minus 4 by a cube, this minus sign will come out, and a by 2, and if we put the limit, then this is 0 minus 1, so we get 2 by a square. That is option D. So option D is correct. So this was a really easy problem. So I think everyone could solve it. And if still there is any question, you can ask. Is there any question?
No, sir.
Then we move to the next question. So in the next question, this is a GATE Physics 2012 question number 40. The ground state wave function for the hydrogen atom is given by, this is the ground state wave function, and where a0 is the Bohr radius. The plot of the radial probability density PR for the hydrogen atom in the ground state is, which plot is correct? You need to find this. So again you can try and solve first. and let me know when you are done.
Sir, D.
Yes, option D is correct. As you can see that the wave function, the ground state wave function is 1 by root 4 pi 1 by a naught to the power 3 by 2 exponential minus r by a naught. Now where what is need to calculate is the probability density of the radial part, that is this is need to be calculated. So the radial part here is this part, so 1 by a naught cube exponential minus twice r by a naught into r square. So this is PR, but we are given the plot of PR. So as we can see from this function, this is r and this is PR. So for small r this will dominate, and for large values of r this exponential part will dominate. So for small r this is like a parabola like this, and for large values of r, this since this function is dominating and this is exponentially decaying function, so it should decay like this. So for our case on option D looks like our this graph. So option D is correct. From this function we can qualitatively say that option D is correct, for because any or A, B and C are not looking like this curve. So this option is correct. I think it is also clear to everyone. And if still there is question, you can ask. Or else we'll move to the next question, because the next question is a bit lengthy and it is algebra just. So since there is no question, I'll move to the next question. So this is a 2014 question number 27, that an electron in the ground state of the hydrogen atom has the wave function. Again and again we are getting the ground state wave function, so you should remember what is the ground state wave function. And a naught is the constant, which is basically the Bohr radius, and the expectation value of the operator q. If it is not clear, then I'm writing at that q is z square minus r square, where z is r cos theta, it is r cos theta. Then you need to find out the expectation value of q. In the first question we have found out the expectation value of 1 by r square. So in the similar way we need to find out this expectation value of q, and you have to use this in the subsequent calculation. You will have to use this formula, that this is gamma n plus 1 by alpha to the power n plus 1, where gamma n plus 1 is factorial n alpha to the power n plus 1. Using this you can find out the expectation value of q. So this is a bit of algebra, so this is basically straightforward. First calculate the expectation value of z square, and if you can find out the expectation, that is r square cos square theta, and then find out the expectation value of r square, and let me know the answer of this too. If you can calculate this one, then this is basically just come out from here only, so you don't need to calculate it explicitly. So let me know the expectation value of z square first. And directly use this formula because it is given in the question itself. So use this property and find out the expectation value of z square. Has anyone solved it?
Expectation value of z square equals to a naught square.
Yes, exactly. It will come out a naught square. And if you solved the expectation value of r square, it is 3 a naught square. So anyway, I will solve it. So first let's calculate the expectation value of z square, that is r square cos square theta. So similarly it is the ground state wave function. So this is 1 by pi a naught cube e to the power minus twice r by a naught r square cos square theta, and the volume element which is r square sin theta dr d theta d phi. So this is constant, so it will come out. We'll write the angular part and the radial part separately. So r to the power 4 exponential minus 2r by a naught dr, and the angular part is theta is from 0 to pi cos square theta sin theta d theta, and phi is from 0 to 2 pi d phi. So for this part we'll use this formula. So 1 by pi a naught cube, in this case n equal to 4 and alpha is 2 by a naught. So if we use directly this formula, then factorial 4 by 2 by a naught to the power 5, and this phi integral will give us 2 pi. So we only need to calculate this theta integral. So if we do it here in graph, then if we substitute cos theta as p, then minus sin theta equal to minus sin theta d theta equal to dp. So we substitute here. Also we need to change the limit theta to p, theta 0 to pi. When theta is 0, p is cos theta, so cos 0 is 1, and when theta is pi, cos pi is minus 1. So limit will also change, so 1 to minus 1 p square dp, and one minus sign will come out because of this minus sin theta d theta. So this will give us minus p cube by 3 and 1 to minus 1. So this is minus 1 by 3 minus 1 by 3, that is minus 2 by 3, and this minus will give us, this is 2 by 3. So this integration will give us 2 by 3. So if we put this value here, what we get is 1 by pi a naught cube into factorial 4 is 24, this is a naught to the power 5, 2 to the power 5 is 32 into 2 pi into 2 by 3. So there will be, this is 3 4, this pi cancels out here, 2 cancels with 4, and 3 also cancels out, so we are left with a naught square. So the expectation value of z square is basically a naught square. Similarly, the expectation value of r square is r square 1 by pi a naught cube minus 2r by a naught. Since here we don't have any theta or phi dependence, we'll directly write it as 4 pi r square dr. Whenever there is no theta or phi dependence, we can write the volume element as 4 pi r square. So what we get is this pi cancels out, 1 by a naught cube, 4 by a naught cube, yes, this 4 by a naught cube, 0 to infinity r to the power 4 exponential minus 2r by n of dr. So again we will use this property, and we will get is 4 by n naught cube into factorial 4 divided by 2 by n naught to the power 5. So this is 4 into 24 n naught cube into 32 2 to the power 5 and n naught to the power 5. So 3 4 4 4 cancels out, we get 3 n naught square. So we are supposed to calculate the expectation value of q, right? And q is z square minus r square. So this is basically n naught square minus 3 n naught square minus 2 n naught square. So for this question, option D is correct again. So option D is correct, that is minus 2 n naught square. So I hope this is clear, and if not, you can ask wherever you have doubt. This was a bit lengthy question, so I think the marks of this question was higher. This was also just algebra. So if it is clear, we can move to the next question. This was also from 2014 GATE question number 32. A hydrogen atom is in the state psi. The state is given as the combination of these states minus root 3 by 7 psi 310 plus root over of 4 by 21 psi 321, where n, l, m in psi n, l, m denote the principal, orbital and magnetic quantum numbers respectively. If L is the angular momentum operator, the average value of L square is the numerical value need to find out. So calculate the average value of L square. So this is also really straightforward. So first you guys try, and then I will solve. So this kind of questions are asked in GATE question paper. You need to know the expectation value of L square is L into L plus 1 h bar square. Use this property, the eigenvalue of L square is this, then you can find out the average value of L square in this given state. And in the similar note, the eigenvalue of Lz, the z component of the orbital angular momentum is m h bar. Here L is from
So answer 2.
Yes, the right answer is 2. What about the others? Could anyone else solve it? Priyanka, have you found 2? Hello, Priyanka, are you there?
Yes, sir, I'm just trying.
Okay, okay, okay. Yeah, carry on. And keep in mind that the weight factor of this each wave function, that is the probability, this will also come into the picture. So as I was talking about this L is the same, this L, and M is this L, that is the magnetic quantum number and the orbital quantum number. So since there is not much time, I will solve this question. So psi is given here. For the first wave function, this psi 200, the value of L is 0. This is N, this is L, and this is M. Similarly for psi 310, L is 1, and for psi 321, L is 2. So the expectation, so the eigenvalue of L square for this state is L into L plus 1 into h bar square, which is 0 because L is 0. And for this state, this is 1 into 1 plus 1 into h bar square, that is 2 h bar square. And for this state, this is 2 into 2 plus 1 h bar square, so 6 h bar square. And the probability of 0 is 8 by 21, so the total average value of L square is 8 by 21 into 0 plus this root 3 by 7, so 3 by 7 into 2 h bar square. The probability of getting 6 h bar square is 4 by 21 into 6 h bar square. So this is 0, and we get 6 by 7 h bar square plus 24 by I think so. Wait a minute. Yeah, 24 by 21 h bar square. So if we calculate it, we'll get 18 plus 24 into h bar square, so 42 by 21 h bar square, which is 2 h bar square. So the numerical value which was asked in the question would be 2. So these kind of questions, if the total wave function will be changed, and if we get some other wave function, only the value of NL and M will be changed, and the same question might be asked. So this kind of question can be solved in this way, and this is really straightforward. So I hope this is also clear to everyone. have one more problem there, I think. Yeah, get physics 2022. So I think I can solve this question as well. So in this question, get physics 2022, question number 48. This question, it was asked that a particle of mass m is moving inside a hollow spherical shell of radius a, so that the potential is Vr equal to 0 for r less than a and infinity for r greater or equal to a. The ground state energy and the wave function of the particle are E0 and r of r respectively. Then which of the following options are correct? So the potential Vr is 0 for r less than a, infinity for r greater or equal to a. So this is basically an infinite potential well, but 3D infinite potential well, spherical. So we the options are given for radial wave function, and the energy also come out from the radial wave function. So we need to solve the radial wave function. For this case, the radial wave function reduces to d2u one minute. Yeah, minus h cut square by twice m d2u dr2. If we directly write down, if we directly write down for r, we don't need to write it in terms of u. Then it is d dr of r square dr of dr minus 2m r square by h bar square Vr minus e r equal to L into L plus 1 r. So for the ground state, let's put L equal to 0 for to make it easier this calculation, and here Vr is 0 for r less than a. So if we put these two conditions, then d dr of r square of dr minus 2m r square h bar square, sorry, it will be plus er equal to 0. So this is basically, we can write this as minus h cut square by twice m d dr of r square dr of dr equal to, if we, this is ground state energy, so this is E naught r, right? So we get this kind of this kind of equation for the radial function, and it is similar to option C. And since it is a multiple choice question, there can be more correct answer, and we need to check each options. If we solve it, we can solve the radial equation. The radial equation basically is given as d2u dr2 minus, plus k square u equal to 0, here k equal to root over of 2m e by h bar. This is come out from the radial equation that involves u. You can easily find it. Let me do it, because the radial equation with u is h bar square by twice m l into l plus 1 r square u equal to E0 u. Now this is 0 and L is also 0, so this part is not there. So this is basically 0, the effective potential is 0, and what we get is d2 u dr2 plus twice m e naught by h bar square u equal to 0. So basically this is what we get, and if we solve this equation, we'll get u of r as a sin kr plus b cos kr. But u is not what we are looking for. We are finding r of r, and r of r is basically u of r by r. So r of r, the radial wave function, is sin a sin kr by r plus b cos kr by r. Since the wave function should be finite at every point, then b has to be 0, otherwise this will blow up, because sin kr is 0 at r equal to 0. If we put r equal to 0, then this is already 0, but this function will blows up. So from this condition we get b equal to 0, and from the boundary condition that requires that sin ka at a, since if this is the sphere, this r equal to 0, this is r equal to a. At r equal to a, that is outside the sphere, psi should be 0. So from the boundary condition at r equal to a, we get that sin ka should be 0, and we get the condition that k equal to n pi. And from this condition, if we apply it in this value, that k equal to root over 2me by h bar, we get e equal to n square pi square h bar square by 2m a square, where n is 1, 2, 3 and so on. So if we put n equal to 1, then E0 is pi square h bar square by 2m a square. This is our ground state energy. So this will satisfy option A, this value. So option A and C is correct, and option B can't be correct, because we found out that the equation for the radial part is like this and not like this. So option B is not correct, and we are left with option D. So as we have found that r of r is, since b is 0, a sin kr by r, and k is n pi by a, right? So k is n pi by a. So if we put the value of k, so sin n pi r by a by r. Now for ground state, n equal to 1, that is pi r by a divided by r. So so option D is also correct. This a is normalization constant. We will find out the normalization constant by this condition. So basically this is r of r is of the form of this, that is option D is also satisfying. So for this question, option A, sorry, not B, option C and option D, all of them are correct. So for this question, if you have any question, you can ask. Otherwise we are already 6:04 it is already, so we are already out of time. If there is question, you can ask quickly. Otherwise, I will end the session because it is already 1 hour.
Sir, for a particle in sphere, only we encounter this type of problem or any other kind of problems?
Look, I have searched for the question from 2010 to 2022, and I have encountered with this type of questions only. There might be other questions as well, but these type of questions I have found.
Yes, sir.
For hydrogen atom, these type of questions are only asked.
Sir, at the last question,
Yes.
can you please explain why option C is correct?
Option C is correct, right?
Sir, option B should be correct and C should be incorrect.
Have I made any mistake? Minus h square square by 2m ddr. Let me check the wave function, the radial part equation. I might be wrong. So the radial part is ddr of minus. Yeah, there should be 1 by r square. So minus h square by 2m 1 by r square ddr of r square here. Yeah, this is matching with option B and not option C, right? Yeah. Sorry. That's wrong. So this equation, this is matching with option B. This is right. So option B is correct, not option C, because this is exact. I missed that r square part, and so yeah, option B is correct. So is your question cleared?
Yes, sir. Yes, sir.
Yeah, option B is correct. Sorry for the mistake. So if there is no question, we can end the session here. So in the next session, I will discuss about angular momentum and spin and the related gate questions. And if I find any different type of questions from this hydrogen atom, I'll add that too.
Okay, sir. Thank you, sir.
Yeah, thank
Thank you,
you.
sir.
Yeah, thank you. So bye everyone.
Bye.